Avesh.
Sir, in Trivandrum, it's a good rain. It's raining. I think your mic is mute, sir.
Good morning. Good morning. Dr. Suresh Das, good morning. You are not audible, sir. I think he has some problem with the mic.
Yes. But he has checked his mic and presentations better.
Oh.
Yeah, can you hear me now?
Yes, sir.
Yeah. It said that I can't unmute myself. That is why I need permission to unmute. Okay. So now I have that. Oh, good morning, Dr. Sudhir. Good morning, Dr.
Good morning, sir. Good morning.
And everybody else. Yeah. No, I came here yesterday night. I know we have been having heavy rains in Trivandrum. Here is nice and dry. Absolutely. Today also it's raining in Trivandrum?
Yes.
Raining, sir.
Yeah.
I think the whole day there is a rain, and tomorrow onwards it is clear sky.
I see. How are you, Sarika?
Fine, sir.
Nice to see all of you.
The time is now 11. Let us start.
I think
63 people joined, sir.
Okay. I think, Sarika, we can start.
Okay, sir. A very good morning to you all. On behalf of Kerala State Council for Science, Technology and Environment, I extend a warm welcome to all the participants to the 8-month program conducted as part of the Azadi Ka Amrit Mahotsav initiative of the Government of India. The program being conducted to commemorate the 75 years of Progressive India. The Department of Science and Technology, Government of India, and the State S&T Councils have joined hands in organizing the 1-month, 1-theme initiative as Vigyan Utsav. The theme for this month is Science and Society. Before moving to today's program, let's see a short video about Vigyan Utsav.
15 अगस्त 2021 को भारत ने अपना 75वां स्वतंत्रता दिवस बड़े धूमधाम से मनाया और साथ में माननीय प्रधानमंत्री श्री नरेंद्र मोदी जी ने लाखों करोड़ों लोगों में नई ऊर्जा और चेतना जगाई। उसी चेतना को बढ़ाने के लिए देश के सभी विभाग, विशेष कार्य विज्ञान और प्रौद्योगिकी विभाग द्वारा नावीन्य कार्यक्रम का आयोजन किया गया है, जिसका नाम है विज्ञान उत्सव। विज्ञान उत्सव कार्यक्रम सितंबर 2021 से अगस्त 2022 तक चलेगा, जिसे डिपार्टमेंट ऑफ साइंस और टेक्नोलॉजी गवर्नमेंट ऑफ इंडिया विज्ञान उत्सव कार्यक्रम में STI के लगते विषयों आधार विभिन्न प्रकार की प्रवृत्तियां होंगी, जिसमें राज्य स्तर पर STI संस्थान, मानव क्षमता विकास, R&D इंफ्रास्ट्रक्चर, स्वदेशी प्रौद्योगिकी, नवाचार और स्टार्टअप, विज्ञान संचार और लोकप्रियता, महिला वैज्ञानिक, विज्ञान और समाज, फ्यूचर टेक्नोलॉजी, आत्मनिर्भरता के लिए बुनियादी विज्ञान, आत्मनिर्भरता और उद्योग और बौद्धिक संपदा अधिकार जैसे विषयों को शामिल किया गया है। विज्ञान उत्सव कार्यक्रम हमें आत्मनिर्भर भारत की ओर ले जाएगा। विज्ञान उत्सव में भारत के अलग अलग राज्य के एसएनटी काउंसिल्स भागीदार होंगे, जो अपने राज्य की विज्ञान प्रवृत्तियां और नवाचार के विभिन्न पहलू की झांकियों का प्रदर्शन करेंगे। इसी के साथ हम सब अपने आत्मविश्वास को आत्मनिर्भर भारत के लिए बुलंद करेंगे। इसे आप YouTube चैनल और SSTP के वेब पोर्टल पर देख सकते हैं। आइए आजादी का अमृत महोत्सव हम सब मिलकर विज्ञान उत्सव के साथ मनाएं। विज्ञान उत्सव, हम सबका अपना उत्सव।
Welcome back. Now let's move on to the program. May I invite Dr. S. Pradeep Kumar, the Member Secretary, Kerala State Council for Science, Technology and Environment, to welcome the distinguished guests and participants. Over to you, sir.
Thank you, Sharika. Professor K.P. Sudhir, Executive Vice President, Kerala State S&T Council and Ex Officio Principal Secretary, Department of Science and Technology, Government of Kerala. Dr. Suresh Das, former Executive Vice President, Kerala State S&T Council and former Director, CSIR NIST, Thiruvananthapuram. Professor George Thomas, Chairman, Kerala State Biodiversity Board. Sri Biju, Environmental Engineer, Kerala State Pollution Control Board. Dr. Abhesh Raghavan, Center for Science in Society, Kusat, Cochin. Dr. Sija Thomachan, College of Horticulture. Srimati Neetu Emmanuel, Pair Awardee. Sri Akhilesh, APJ Abdul Kalam Youth Challenge Program Awardee. Sri Eldos Raju, Vishwajyoti College of Engineering and Technology. Devananda from Kendriya Vidyalaya, Calicut. The member secretaries and other officials of different state councils, directors, scientists, and other officials of different R&D organizations, officials from Department of Science and Technology, Government of India, Dr. C. Anil Kumar, Dr. Sharika, my colleagues, dear friends and participants. A very good morning to one and all. Welcome back to the next session of the Azadi Ka Amrit Mahotsav, the celebration of the 75th anniversary of Indian independence. As you are aware, to commemorate this monumental occasion, the science and technology people set our celebrations with the STA ecosystem with 1 month, 1 team initiative for a resurgent Atmanirbhar Bharat. Today, we will be discussing the role of science in society. The lead speakers and those who are here to share their experience is surely enrich all of us with the thread that links science with society. It is true that we live in a knowledge society. Knowledge, in addition to mineral resources, capital, and physical activity, is an increasingly important resource. It contributes to the functioning of democracies and innovation and helps countries to be competitive on global scale. But science which contributes significantly to knowledge production is confronted with new challenges. Science is one of the most important channels of knowledge. It has a specific role as well as a variety of functions for the benefit of our society, creating new knowledge, improving education, and increasing the quality of our lives. Science must respond to societal needs and global challenges. Kerala State Council for Science, Technology and Environment has various programs to go deep into the society with an objective of science popularization, promotion and sustenance of quality, and excellence in science education at all levels, starting from school level to university level. The details in this regard will be presented by Dr. C. Anil Kumar. Let me come back to my responsibility of welcoming the gathering. Professor K.P. Sudhir is the key person of the Kerala State Council and leading the council at various levels. I sincerely welcome you, sir, to this program. Dr. Suresh Das, former Executive Vice President of Kerala State Science and Technology Council and former Director, CSIR NIST, and now he is working at ISER Trivandrum, is the keynote speaker today. He has readily accepted our invitation and agreed to deliver the lecture. I cordially welcome you, sir, to this occasion. Professor George Thomas, Chairman, Kerala State Biodiversity Board, has agreed to share his vast experience as a professor of agronomy and as the Chairman, Kerala State Biodiversity Board. I sincerely welcome you, sir, to this function. Sri Biju from the State Pollution Control Board will be discussing the hot topic of the waste management, and it remains as an example how science implies to the daily life of a human being. I welcome you to this function. Dr. Abhesh Raghavan from Center for Science in Society, KUSAT, Cochin, an organization working for the popularization of science and technology among children, will be delivering a talk on scientific temperament. I welcome you to this function. Dr. Sija Tomachan, Dr. Neetu Emmanuel, Sri Akhilesh, Sri Eldos Raju, Devananda, the prestigious fellowship awardees of KCST are here to share their vast experience. I sincerely welcome each one to this function. I sincerely welcome Dr. Datta, Dr. Reshmi Sharma, and Dr. Ravikant Prajapati, Department of Science and Technology, Government of India, to this function. I welcome all the member secretaries and officials of different state councils, directors and scientists of various R&D institutions to this function. I sincerely welcome all the participants who showed real interest in this program. Dr. C. Anil Kumar coordinated this Kerala episode of Azadi Ka Amrit Mahotsav. I congratulate him for his effort and welcome to this function. I welcome and congratulate Dr. Sharika, Sri Sunil Kumar and Jay Krishnan for their efforts for the successful and smooth conduct of this program. I welcome all my friends, colleagues, and all those who had gathered here to witness this function. Thank you. Thank you all once again.
Thank you, sir. Professor K.P. Sudhir is the ex officio Principal Secretary to Department of Science and Technology, Government of Kerala, and the Executive Vice President of the Kerala State Council for Science, Technology and Environment. I now invite Professor Sudhir for the presidential address. Over to you, sir.
Thank you, Sharika. Am I audible?
Yes, sir.
Good morning, everyone. Dr. Suresh Das, Dr. Joe Thomas, Mr. Biju, Dr. Abhesh, Dr. Datta, Dr. Rashmi Sharma, and other colleagues from Department of Science and Technology, Government of India, my colleagues from KSCSTE, other dignitaries present here, dear participants, and the keynote speakers. Very good morning to all of you. It's indeed a pleasure for me to be here on the 8th month program of Azadi Ka Amrit Mahotsav, initiated by the Department of Science and Technology, Government of India. It's indeed, initially we were wondering what is the 1 year long celebration we have to do in science and related activities. But then as the time progresses, we realize that 12 months are not enough to discuss various aspects of science and technology development. And I would like to appreciate the organizers from the Government of India for this first. Well, we have been discussing on various topics in the last 7 months. And this month, the theme is Science in Society, which is very relevant these days because various, the government is pumping a lot of money in research and development, specifically in science and technology. And these developments of the technologies or even the new knowledge, what is its implication on the society is always questioned. In fact, when we go for funding for different projects with the funding agency, the first question they ask is, what is the relevance to the society, which is very much needed these days. In the earlier years, probably 15, 20 years back, if you look at fundamental science has been the focus of research, advancing the current knowledge to different levels. Now, the application of the new knowledge into new products or processes has become more important. And that specifically has to impact the society for their benefit and their betterment. And I guess most of the science and technology institutions have programs related to taking the information or taking the knowledge to the societal level. I remember the Agriculture University in the early days, they had a program called Lab to Land. Whatever you have developed in the lab was taken into the land directly by through extension activities, farmers. And similarly, we have several programs instituted by different institutes directly taking the results of your innovations and findings and new knowledge to the societal level. And now the children, the students of the society are interested in learning and learning more and more things. And with the advent of, I would say, information technology, this reach has become more easy. But at the same time, I would also like to give you a warning. The social media has been used for positive and negative aspects as well. So when you hear a news, immediately the pros and cons and twisted messages come in the social media, and you don't know which one is true and which one is false. And that has become a very difficult task now. In fact, several news media has now a program called Finding the Facts. So when you get a news in your maybe a mobile phone or through some messenger, and you don't know whether it is really true or not. There is virtually, some people call, there is something called WhatsApp University, and all the results are disseminated through WhatsApp University, which is alarming. In fact, that kind of an activity basically reduces the importance of the actual scientific innovations and technology which we develop through a lot of research activities. And then that is what we are trying to basically now reduce through different aspects. And I guess these kind of programs initiated by the Department of Science and Technology and the State Science and Technology Council will help generate an awareness about these kind of malpractices or misuse of facilities. If you look at the Kerala State Council for Science and Technology, we have been doing a lot of activities to promote science, popularize science, and to make these inventions into the society. I am sure that my colleague Dr. Anil Kumar will be giving you a presentation about the program details of the Kerala State Council for Science, Technology and Environment. In particular, we would like to mention, as Dr. Pradeep mentioned, starting from the 12th standard students till the postdoctoral fellows, we have schemes for conducting research and disseminating results into the society. We also hold on a regular basis the annual Kerala Science Congress, annual event of the council, which basically invites most of the researchers and gives a platform for interaction for this interdisciplinary research. And all these things are promoted these days. I would say some of the activities which we used to have on a physical basis in different locations in the state was put on hold due to the COVID pandemic in the last 2 years. Now we are coming back to the same kind of activities and going on the physical mode. In fact, we had conducted the last year Science Congress was fully on virtual mode. And this year's Science Congress was, basically hybrid mode. Both years were hybrid mode. This year we wanted to have it on fully on the physical mode, but then the sudden surge of the COVID pandemic again made us to go on the hybrid mode. So last physical activity of the Science Congress was in 2020 in Palakkad, and we hope that with the reduction in the COVID cases in the next year, to 2023, the Kerala Science Congress can be held on a physical mode at a good location where most of the researchers can participate and interact. We were also having some programs for benefiting the society, like we conduct rural innovation meets, primarily to promote the scientific temperament among the rural people. And their inventions are really nice. So they don't have a proper scientific background of the invention, but then we give technological support to them and then try to promote their inventions into popularizing and getting into different, probably into commercial level. So in a nutshell, State Council conducts a lot of programs and schemes which basically looks at promoting the science, research, and bringing it into the societal level. I guess my colleague will detail on that, and I don't want to speak a lot about it. But then I would also like to mention that there is one institute which recently have joined the council, which is the Council for, the Institute for Climate Change Studies. They are also doing a lot of activities in association with the State Disaster Management Authority and Government of Kerala in disseminating information about the weather which is anticipated in future. So primarily the institutes of the council, the scientists of the council are doing a lot of activities to bring the scientific advancements into the society and for their better living and planning. I don't want to extend it anymore. So thank you very much, the organizers, for giving me an opportunity here. And also I would like to appreciate the efforts put in my colleagues, Dr. Sharika, Dr. Anil Kumar, and their team in developing this wonderful program. Thank you very much.
Thank you, sir. To detail the science programs with societal outreach from the state and the initiatives of Kerala State Council for Science, Technology and Environment, I invite Dr. C. Anil Kumar, the Senior Principal Scientist of KCSD. Sir, please.
Thank you, Dr. Sharika. Good morning, everybody. Let me share my presentation. Yeah, is it visible now?
Yes, sir.
Okay, thank you. Respected Professor K.P. Sudhir Sir, Executive Vice President, KCSTE. Respected Dr. S. Pradeep Kumar Sir, Member Secretary. Dr. Suresh Das Sir, Professor George Thomas Sir, Sri Biju, Dr. Abesh Raghuvaran, dignitaries from DST and state S&T councils, my colleagues and dear friends. It's a great privilege and honor for me to present the science and society activities of KSCSTE. While talking about science and society, the first name came to my mind is the name of our first Prime Minister, Pandit Jawaharlal Nehru. As per his words, it is science alone that can solve the problems of hunger and poverty, of insanitation and illiteracy, of superstition and deadening custom and tradition, of vast resources running to waste in a rich country inhabited by starving people. All we know that science generates solutions for everyday life and helps us to...
Excuse me, sir, a slide is not moving.
Yeah, okay, thank you. We know that science generates solutions for everyday life and helps us to answer the great mysteries of universe. In other words, science is one of the most important channels of knowledge. It has a specific role as well as a variety of functions for the benefit of our society, creating new knowledge, improving education, and increasing the quality of our lives. To face sustainable development challenges, governments and citizens alike must understand the language of science and must become scientifically literate. On the other hand, scientists must understand the problems policymakers face and endeavor to make the results of their research relevant and comprehensible to the society. When we come to the science and society programs of Kerala, Kerala is now transforming into a knowledge society. Today, most technologically advanced economies are knowledge-based. The influence of science in society is very clearly visible in Kerala and is evidenced by the highest Human Development Index. This is achieved through the research and development activities in Kerala, educational institutions in Kerala, NGOs in Kerala, print, electronic media, science museums, science parks, etc., etc. Fortunately, in Kerala, we are endowed with 12 universities, including a central university, 24 state R&D centers, 20 central R&D centers, and many NGOs. When we come to the science and society programs of KSCSTE headquarters, KSCSTE is operating 66 schemes and programs for the benefit of different sections of the society. All these programs contribute to societal benefits in different ways. First program came into my mind is the Kerala Science Congress. For the last 5 years, around 10,000 scientists participated in this program, including the keynote speakers, delegates, postgraduate and undergraduate students, industry persons, child scientists, exhibitors, etc. And another program is exclusively for the students. This include the National Children's Science Congress. For the last 5 years, around 451 projects were presented and a number of projects received a national award. And scheme for promoting young talents in science, SPITES. This is exclusive for the school students. And for the last 5 years, 726 projects were presented. Another highlight is a student project. It is one of the flagship program of KSCSTE. And for this program, we are getting a matching grant from the DST. And for the last 5 years, around 1,750 projects were presented during these last 5 years. And when come to the national days of importance, we are celebrating the World Wetland Day, National Science Day, National Technology Day, World Environment Day. It's not moving.
Meeting.
Slide is not moving.
Meeting.
Yeah, okay, it's moving. So World Environment Day, Mathematical Day, etc. And with regard to the science communication programs, we have the P.T. Bhaskara Science Writing Fellowships. For the last 5 years, around 6 books were published. Shastra Samyuksha, another program for the students during the vacation period. And we have established another research equipment awareness portal, REAPK, exclusively for a web-based facility of the inventory of the instruments in Kerala. That is open for all. And also we have published the Shastra magazine. And with respect to the nature conservation activities, KSCSTE is the nodal agency of the NGC and Eco Clubs. And annually, 4,000 Eco Clubs are supported with a grant of rupees 5,000 each. And every year we are giving 100 awareness programs. And for the last 5 years, 100 training programs were conducted, 500 awareness programs, and 45 nature camps. Another important achievement is the establishment of Envis Hub. Kerala is implementing the GSTP courses, Green Skill Development Programs. And for the last 5 years, 283 students were trained in this program. And also Envis Hub is providing much information about the environmental activities of Kerala. And with regard to the collaborative projects, we have Shastra Bodhini program, Crystal program, PAIR program. Shastra Bodhini is an external funded program with the ST department exclusively for the development of the model residential schools in Kerala. And Crystal is for the students during the vacation period attached with the R&D Institute. And PAIR is another achievement, and PAIR project on the development of low-cost handheld Raman spectrometer for the automated analytical and diagnostic applications was awarded the CSIR Technology Award 2020 under the innovation category. And when it comes to the women in science activity, we have facilitated around 71 women scientists during the last 5 years. And 36 women researchers could complete their PhD through the Back to Lab Fellowship Program. And with regard to the rural technology, we have the Rural Innovators Meet, Tech First, etc., etc. With regard to IPR, intellectual property rights, we have a number of awareness programs, and around 15,200 researchers were sensitized for the last 5 years. 32 patent applications were filed, 13 patent granted, 11 copyright applications filed, 17 industrial design applications filed, and 19 trademark applications filed, 4 geographical indicators filed. And another achievement is the KSOM project, Karamana River Scientific Management Pilot Project, a model for coordinated activity in river pollution abatement by involving government departments, institutions, and public, which can be copied to other rivers and wetlands. Vigyan Sarvatra Pujyate. Last month we have celebrated this in connection with the 75th year of independence. Independence Asadika Amrit Mahotsav. We have the Science Expo, science lectures, science book fair, space on wheels, demonstration of science experiments, posters, etc. KSCSTE is having 8 R&D centers functioning in different various thematic areas of science and technology. They are all contributing in many science and society related programs. The Tropical Botanical Garden and Research Institute. They are contributing a lot in the science and society activities. Some of the highlights are the Jyotis program, a contact and awareness program to equip and empower higher secondary science students towards research aptitude development, value addition training program on medicinal plants in different gram panchayats, then 1 month course on quality planting material production, etc. The Center for Water Resources Development and Management, CWRDM, situated in Kozhikode, they have a number of programs. The highlights are the Jiva Jalam awareness program on conservation of and effective utilization of water sources, micro irrigation method of wick irrigation for farmers and households, etc., etc. And another R&D contributing to the area is the Malabar Botanical Garden and Research Institute of Plant Sciences. They have a number of programs, including the Sundaram Sudhiram Haridabham program, the pond renovation program, then certificate course in management and small botanical garden, etc. And also rural empowerment through technology interventions. The National Transportation and Planning Institute, Research Institute, NATPAC, is situated in Trivandrum. They have a number of programs directly connected with the science and society activities of the people of Kerala. Road safety education through schools in Kerala in association with the Kerala Road Safety Authority, training on safe transportation hazardous goods, safe handling of dangerous and hazardous goods, safe community program for panchayat, training program for driving school instructors, road safety youth leadership program, etc., etc. And we have the IRTC, Integrated Rural Technology Center, situated in Palakkad. IRTC is a center of excellence in waste management and an accredited agency of Government of Kerala for preparing watershed DPR. The technologies developed by the IRTC have made an impact on rural lives and is classical example on how science influences society. And also we have the MS Swaminathan Research Foundation and the Center for Thank you.
Former Executive Vice President of Kerala State Council for Science, Technology and Environment, and the former Director of CSIR, National Institute for Interdisciplinary Science and Technology, Thiruvananthapuram, to deliver the keynote address. Dr. Das obtained his PhD in chemistry in 1981 from the University of Newcastle upon Tyne, UK. After several postdoctoral research positions at international reputed institutions, he joined as head of the newly established Photochemistry Research Unit in 1989 at the National Institute for Interdisciplinary Science and Technology, Trivandrum. There, he was instrumental in establishing a leading group and the state-of-art facilities for conducting the research on basic and applied aspects of photochemistry. He is a fellow of the International Science Academy, New Delhi, and the Indian Academy of Science, Bangalore, and a recipient of several prestigious awards. He is currently the Emeritus Professor at the Indian Institute of Science Education and Research, Thiruvananthapuram. It's my pleasure to invite Dr. Suresh Das for the keynote address. Over to you, sir.
Thank you, Dr. Sarika, for your very kind introduction.
Thank you, sir.
I will share my slides.
Okay.
Are you able to see my screen?
Yes, sir. Yes.
Yeah. Are you able to see and see my slides and hear me?
Yes. Yes.
Okay, thank you. Let me first of all thank the KSCSTE and Dr. Sudhir and Dr. Pradeep Kumar and all others, Dr. Anil Kumar, for the invitation to talk at this meeting. And what I would like to do, we heard, of course, we all know that in our country, since independence, we have made a lot of progress with regard to science and technology. We have established very large institutes. And society has definitely benefited by the research that has been conducted in many of these institutes. But Dr. Sudhir also mentioned that there is a great concern about how the science that is done in many of these major institutes can actually transfer into society. And so what I would like to do in this short time that has been given to raise some thoughts about, what are the impediments in the science reaching society. And we can also look at, for example, how some of the other countries, how they have been successful in implementing or getting the science that is done to benefit society at large. So these are some of the thoughts that I have just put together. And so traditionally, for example, when we think about science and society, we think about science that is being done in some of the best institutes, and which then converts into some kind of technology which finally reaches society. So this is the scheme that I have shown here. But there is a problem with some of this in the sense that there is, I'm sorry, there's something that's come up in the screen.
No, sir.
Yeah, okay. So my screen is not moving. Yeah.
Yeah. So, yes, sir.
Yeah, so there was some reason the screen was not moving. So, when you really look at how science and technology really interacts with society, it is not that it is a hierarchical movement of science that is done in the institutes moving towards technology, then into society. It's actually, in a functioning system, it has to be a three-way interaction. It's a three-pronged interaction. So what the kind of science that we do in the institutions affects technology, but the kind of technology that is developed also affects the kind of science that is done. And it's also, all of these also have an impact on society, and society itself has an impact on science. It is only when these three things come together that a society becomes that science is truly percolating all the way into society. So let me give you a few examples where actually instead of the hierarchical science to technology to society, how it actually went the other way around in some cases. Okay, so let's take the case of Henry Ford. He was a machinist who left school at the age of 15. And we all know he perfected the techniques of mass production of automobiles. Okay. And let's take another example, the Wright brothers. They were a pair of bicycle mechanics, and they invented the aeroplane. And the refinement of the aeroplane, the science of flying, was modified and perfected much later. Okay? And also when you look at the Edison, his electric light company was illuminating whole of New York City much before electricity was taught as a subject in engineering in the universities. So you can see how societal impacts have actually led to this into technologies which have then affected science. And that is possible when the power to use knowledge exists at different strata in society. And that is what I would like to address in this talk. Okay? And why this is a map, I do not know if how many of you have seen this. This is a map of the world. But normally we show the size of these different countries as proportional to the land mass. But what this figure has done is shown the map of the world as a proportion of its knowledge. So if you take, for example, the United States, you can see it is very large because the knowledge content in that country is very high. Whereas you look at countries like Africa, and we can almost also hardly see India. So this is the proportion of this country is shown, and Europe is very large, okay, and Japan is also very large. So, and contrast this with the global distribution of poverty. Then you can see that this is now the countries are down in proportion to the poverty. Okay, so you can see the countries like Africa and India and China become very large, and Europe and the US practically vanish from this flag. So very, very clearly, you can see that there's an inverse proportion to global distribution of knowledge and global distribution of poverty. So you can see the impact that the knowledge content of a society actually has to that society. Okay. So, in fact, this is something that was tried to be a scientist called Gini in 1912. He tried to quantify what is this, how the societal wealth exists in society, and he developed what is known as a Gini coefficient. And I thought I think it is important to understand, because when we talk about inequality in a society, because inequality in wealth also leads very often to inequality of knowledge. And that is, so we need to understand how we can actually quantify that. And Gini in 1912 actually did that. Okay. Here in this, if you take this slide, what he has done is he has taken something called the percentage of income and the percentage of population. So, and there is a straight line that you can see here. So this is the ideal curve. Basically what we are saying is that in this curve, the straight line curve, 10% of the population will have 10% of the total income of that country. If it is here, 50% of the population will have 50%, and 100% will share 100% of the wealth. So that means there is a situation where, the entire population shares wealth equally. Of course, that is an ideal situation which can never be attained. Then we have the extreme case where you can think about a graph that goes like this, where nobody possesses any wealth, 99% 0% of the wealth, and only 1% possesses all the other wealth. Okay, so that is one. So you can see that you have two extreme cases where wealth is distributed equally, and the extreme case where all the wealth is in one hand. So both are ideal cases, or impossible cases, the extreme ends. So the reality is the curve is somewhere like this. Okay, so this curve describes what is known as the Gini factor, and this ratio defines how the income is shared. So between a ratio of 0 to 1, you have a variation, and as it deviates from 0 towards 1, the income equality increases. So it is shown here in this graph, where you have, in this case, the ideal case, where you have equal wealth sharing, and as you start moving the curve downwards and it becomes more and more steep, it becomes unequal sharing. Okay, so this Gini factor actually affects how society develops. So they say that any Gini factor which is above 0.3, so it is 0 here and it starts moving, it will 0.1, 0.2, 0.3, 0.4, and so on till it will reach 1. Any Gini factor which moves above 0.4 puts stress in society. Okay, and let's take a look at how for example, a country like ours. Okay, this is the data from 2015. That's what I could get. You can see the richest 1% have 50% of the wealth, of the global national wealth, and so the top 10% will have about, so if you look at the population is 1 billion, the top 10% will have 77% of the wealth, whereas the bottom 60% has only 4.7% of the wealth. Now, what has that got to do with the science and technology development in a country? You can see that when you look at the higher end of the spectrum, the life or the status, the people who belong to this group are quite happy with the situation and prefer status quo. Whereas it is the people who are in this squad who want to see change happen immediately. They would like to see the country changed by at least by tomorrow, if not today. That is the urgency with which these people would like to see the country change, develop. But yet, the power to the information and the power to change is not is not existing within this group. Okay, so basically, when we are talking about science and society, what we have to see is that the importance of knowledge percolating down to the deepest level. So, because these are the people who are very keen to bring about a transformation, and in any society, as I gave you the examples in the first slide, where we had people like Henry Ford and others who were belonging partly to this category and not to the other category. And so they were the ones who actually drove a change in that kind of society. So science, so councils, the institutions like our council, Department of Science and Technology, have to are taking, of course, but have to continue taking steps to see how knowledge can percolate to the section of society which is really desperately seeking to try and bring about a transformation. Only then can we see what is the term that is used as creative destruction. Creative destruction, that means the status quo has to be changed, and there has to be a churning, and that churning is if it needs to be empowered, knowledge has to percolate to all sections of society, especially to sections of society which are highly desirous of change to happen. Okay, and you can see that how the Gini factor I mentioned about, and you can see when that the Gini factor comes below 0.3, these are the countries which we normally see as developed countries, and that automatically happens. Okay, when the wealth it is driven both ways, and you can see that countries like South Africa, China, India, Brazil, Mexico, and interestingly, even United States have Gini factors which are not so conducive to the kind of societal transformation that is required. Okay, so so I just want to highlight this by showing other examples of how other countries were able to bring about this kind of transformation. So one of the most important things that happened in Britain was the Industrial Revolution. And when we talk about the Industrial Revolution, of course, there was science being developed in Europe immediately after the close to about 16th, 17th century. But when we talk about the Industrial Revolution, most people talk about the James Watt's perfection of the steam engine in 1765. But why is that point selected as a change for the Industrial Revolution? Okay. Was James Watt a professor in an institution? So when you look at him, he was actually a tradesman. James Watt was a tradesman, and he used to sell instruments to the universities. But every time he was with the universities, the professors used to interact with him, and they used to ask him for inputs. And there was something called the Newcomen engine, which they were having problems with. And when he looked at it and he realized that there are certain ways in which they can improve it, and that is what led to the invention of the steam engine. So again, you can see, the traditional thinking that science from top has to percolate all the way to society is not the kind of system that always leads to the kind of development. When knowledge is available across sections of society, there are other ways in which technologies can develop, and this is one good example. And this is in many of the developed countries have recognized this. And you can see this, for example, Bigelow. He was from Cambridge, and he established the Massachusetts Institute of Technology. All of us are aware of the MIT. But when they established that institution, It was not with the idea of, say, that they were going to be focusing on very high level of research, which it does today. But their basic intent was that there was a lot of scientific knowledge, and they felt that this knowledge and the scientific laws and principles had to be transmitted to the industrial classes, because only it was as a preparation for the labors of the mechanic and the manufacturer. They saw the importance of that knowledge percolating all the way down to the people who actually use their hands and bring about the kind of innovations that happen that can also lead to transformation. So therefore, it's interesting that an institute which started with that philosophy was also the very first to have the name technology established within itself, Massachusetts Institute of Technology. Okay. And again, I just talk about the Morrill Act in 1859. When you looked at you see where they actually went, the government made an explicit law, which meant that the scientific, I'll just read it out, scientific including military tactic, to be teach each of the branches of learning as are related to agriculture and the mechanic arts in such a manner as the legislatures of the states may respectively prescribe in order to promote the liberal and practical education of the industrial classes. So how much of that was focused on bringing about a transmission of knowledge to the levels, as we said, where this can be. And of course, in India also, we have been doing that. I just give this one example, 1958 scientific policy, which is also focused on nurturing scientific enterprise. And subsequent policies, including the most recent policies, have taken efforts, and that is what the science and technology, these initiatives that we are seeing today, like this workshop, these presentations that we are seeing today, and the other initiatives that the Kerala State Council for Science and Technology are taking. They have science outreach and science popularization are also programs that these institutes have been taking. But I think a lot more needs to be done, because what just directly only depending upon transmission from in a hierarchical manner from a scientific institution. We have to create a kind of conducive system where a change can take place, and we can empower sections of society which are interested in seeing the change happen immediately, and empowering them through scientific and technological knowledge and skills can bring about that kind of. I'm happy I've been part of State Council for Technology for a time, and they have these very interesting programs, which many of which were highlighted by Anil Kumar. And many of these have roles where, for example, the rural innovators meet, and the rural technology program, and also the APJ Abdul Kalam program, where innovations that are happening at the grassroots, the council is taking efforts to link them up with organizations which do high-end research and to support. And so therefore science cannot be restricted to within research institutions. It has to percolate. So we have to see science as not being a dispensable luxury, because it is absolute necessity for advancements of our societies, to inform our education, to improve our policies, and to spur innovation, and of course promote rational thinking. So in this context, with regard to promoting rational thinking, I would just like to remind all of you that tomorrow we celebrate the Dr. Ambedkar's birthday, one of the great rationalists of this country. And when we talk about science and technology and percolation of society, the percolation of rational thought into society through science communication is also something very important. So I will just leave you with this last slide, which is something that is disturbing. This is a news that came in 2018. And this is a girl. She's a teenager. And she passed away when we had the cyclone Gaia. That was something that hit India in Tamil Nadu. And the reason she died was because she was isolated in what was known as a menstruation hut. And you can see that this, when we talk about being scientifically developed nation, it is unfortunate that things like this can happen. And so we can see that there is an urgency for science and knowledge of science to percolate to all levels of society. And so with this thought, I will stop my presentation here. And I wish to congratulate all members of the council for organizing this program. And I hope that these kind of activities will bring about the kind of transformation in science, in our society that all of us desire to see. So thank you very much.
Thank you, sir. Thank you for stressing the need for knowledge percolation to all sections of society for the science to have impact on the society. And thank you so much for enlightening us with your words of wisdom as always. Thank you so much.
Thank you. Thank you.
Have Dr. C. George Thomas, who is the chairman of Kerala State Biodiversity Board. Formerly, he was the director of research, Integrated Rural Technology Center, Palakkad. For a long time, he had been with the Department of Agronomy, Kerala Agriculture University, and retired as professor and head. He also served as the associate dean there. His research works are in forage crops, weed science, irrigation, and watershed management. He also taught research methodology and scientific writing to graduate students. It's my pleasure to invite Dr. George Thomas for the invited talk. Sir, please.
Good morning, all of you. Distinguished Executive Vice President, KSCSTE, Dr. KP Sudhir, Dr. Suresh Das, distinguished participants and scientists from KSCSTE and other institutes, participants. Well, I am very happy to be part of this Vigyan Utsav, and I am going straight to this topic because the time is limited. I think I have been given only 15 minutes. So I'll start with the presentation. I hope the presentation is visible.
Yes.
Yes.
Okay. So biodiversity, as you know, it is almost a recent term. Probably when I was a graduate student or a PG student, this particular term, biodiversity, was not there. And it was introduced by none other than Thomas Lovejoy in 1980, biological diversity. That was the term he used. Then a contraction of the term was introduced by Walter Rosen in 1985. And later, Edward Wilson, he popularized the term. He died quite recently only in December 2021. He wrote so many books and he popularized the concept and related many things. So he's often called the father of biodiversity, Mr. Wilson, Dr. Wilson. Well, a small definition is required here. What is biodiversity after all? When we say biodiversity, we mean the diversity of life on Earth. So that means variability within species, between species, and of ecosystem. These three are a part of biodiversity. The species, number of species, and most probably in agrobiodiversity, when we talk about biodiversity, we are more concerned with variability between species. Well, agrobiodiversity is also a part of biodiversity. So it is a vital subset of biodiversity. So it is the result of natural selection process by the farmers, and without human beings, there is no agrobiodiversity. Biodiversity is there, natural biodiversity is there, but there is no agrobiodiversity without the interference of farmers and others, and human beings, we can say. So various definitions are there. Anyway, agrobiodiversity include the harvested products, then the non-harvested products. So diversity of non-harvested species there, diversity of harvested species there, and diversity of wider environment that support agro systems is there. Then the ecosystem where the crops are grown. So all these things are part of agrobiodiversity. That includes food, fodder, fiber, fuel, and pharmaceuticals, medicinal plants, and so on. Well, you may wonder why biodiversity is important, and many people, they have developed equations for quantifying the benefits out of biodiversity to the society. And as we know, everything that lives in an ecosystem is part of the web of life, including humans. Humans are also a part of this web of life. And plants, animals, insects, microorganisms, they interact and depend upon one another for what each offers. So what each offers means it may be food, it may be shelter, it may be oxygen, it may be soil enrichment or something else. And it also plays a role in climate change resilience. So most of these organisms, they also consume carbon dioxide. The producers, they consume carbon dioxide, and it helps in the intake of greenhouse emissions and sequestration. At the same time, they also engage in respiration. Well, some people, especially the Costanza, they are very popular in valuing ecosystem services. So according to them, a recent study from 2011, the study is 2014, but up to 2011, they estimated it at 125 to 145 trillion per year. So that is almost 1.5 times the size of the global gross domestic product, the value of ecosystem services from all the biodiversity angle. So these are some of the ecological services attributed to biodiversity. I'm not going to describe all these things. You may already know this: balance of life in nature, biological productivity, regulation of climate, degradation of waste, cleaning of air and water, cycling of nutrients, control of potential pest and disease-causing organisms, then detoxification of soil and sediments, soil and water conservation, stabilization of river and sea coast against erosion, then carbon sequestration and global role in global climate change, maintenance of soil fertility, and biodiversity also boosts the economy. Well, I have to tell you something about this Brundtland Commission and the Earth Summit. So as we know, the World Commission on Environment and Development is popularly called this Brundtland Commission. Okay, so they were in the forefront to put up a definition about sustainable development. So it was formed in 1983, and they submitted a report that is Our Common Future, and the popular definition of sustainable development, that is development that meets the needs of the present without compromising the ability of future generations to meet their own needs. So this was accepted in 1992, what we call the Earth Summit. So Earth Summit is otherwise called, actually its original name is the United Nations Conference on Environment and Development, but nobody understands if you say that, but that is popularly called Earth Summit. And it was this conference in Rio de Janeiro. So that Rio de Janeiro conference, that is also called Rio Conference, and this the terminology or the term sustainable development was accepted there. And in this Earth Summit, 3 legally binding agreements were signed. So that is what is important for us. That is, one is on Convention on Biological Diversity, that is CBD, Framework Convention on Climate Change, that is UNFCCC, and another one, United Nations Convention to Combat Desertification. All these 3 legal agreements are so important for the society, especially the first 2 one. that is applicable for all world nations. And the Convention on Biological Diversity that was signed so the signing process started in 1982, but at the end of 1993, it was accepted. So the CBD, the Convention on Biological Diversity, so India also signed that, and we are supposed to follow the dictates or agreement in that, and it has got three main objectives.
So it is not moving.
Yeah, okay. Now it is okay, I think.
No, sir. You have to go to the view mode first.
Okay, right. Something happened in my. Can you see the video?
We can see the slides now, but it is not in the view mode.
Okay.
So even in this mode, you can go through the presentation by the slide.
I think since time is very short, I can do like that. Okay. Anyway, you're seeing a slide.
Yes, we can see.
Okay. Anyway, as I told you, the CBD has three main objectives. That is, one is the conservation of biological diversity, the sustainable use of the components of biological diversity, and fair and equitable sharing of the benefits arising out of the utilization of genetic resources. So that means one is conservation of biological diversity. Presentation Slideshow. Okay.
Yes, now it's okay.
Yeah, so two supplementary protocols are also been signed. That is, one is Cartagena Protocol and there is Nagoya Protocol. And this Cartagena Protocol is on the safety of the LMOs, living modified organisms, resulting from biotechnology. And Nagoya Protocol is for the access and benefit sharing part. So that means, according to this protocol, the bioresources are countries, each country's, each country has their own bioresources, and the ownership is vested with them. And if anybody wants to utilize that bioresources, they have to pay an equitable and fair share. So it has been accepted or rather signed in this Nagoya Protocol. So that happened in 2014. Then you may ask a question, how many species are there on Earth? So a recent estimate says there are 8.7 million eukaryotic species. And out of that, 6.5 million are terrestrial and 2.2 marine. But only 20% are listed. That means 1.7 million species have been catalogued. So these are some of the threats. I am not going to all this kind of thing, but just tell you there are natural causes, natural cycles, and anthropogenic causes. So this deforestation and the habitat modification. So these are some of the anthropogenic causes: destruction, degradation, and fragmentation of habitat. Then destruction of rainforest, marine biodiversity is under threat. Then humans are always dependent upon nature for food and shelter. But when needs turns to greed, it leads to overexploitation. Then hunting activities, overhunting, poaching. Then agriculture, of course. So agriculture is mainly responsible for destruction of vast chunks of forest, and agricultural biodiversity is also lost because of modernization of agriculture. And there are some ways to retain or regain the lost glory of agriculture in terms of this. Then invasive alien species, co-extinctions, then human-animal conflicts, we know that, what happens in Kerala. Then, of course, pollution. Then climate change is another threat. So all of us, or all the countries of the world, they are trying to limit the increase in temperature at 1.5 degree. But if it goes above that, if it rises by 2 degrees Celsius, there is a loss of 25 to 40% species may face extinction. So another threat is ocean acidification, then loss of land races, wild races, and so on. So regarding a word about biodiversity conservation, and we talk about in situ conservation, ex situ conservation. I just went through this. In situ conservation, all of you may be knowing, wherever it is there, the bioresources or the organisms, wherever they are protected. That is called in situ conservation. The ex situ conservation means these are taken away and protected in somewhere else, probably in gene banks, probably in zoological gardens or aquariums, and so on. So these are some of the in situ conservation methods: biosphere reserves, national parks, wildlife sanctuaries, community reserves. Then there are some special projects to conserve threatened animals like Project Tiger, Project Elephant, Project Dolphin, Project Snow Leopard. Then special efforts are also launched for conserving Kashmir star, Indian rhino, Indian crocodile, and sea turtle. and of course in Kerala, especially for sacred groves. So it has been said that more than 7,000 sacred groves are in Kerala, often near to a temple, and earnest efforts are needed to protect them. Then gene sanctuary is one. Then on-farm conservation with respect to agrobiodiversity. Then Ramsar wetland site is another treaty. Ramsar sites is different. Ramsar Convention is a treaty, and in India, 49 wetland sites have been designated as a Ramsar site. In Kerala, of course, there are 3. You know the names: Shastankota, Ashtamadi, and Vembanad Court. These 3 are the wetland sites of Kerala. Then exit to conservation strategies: zoological gardens, captive breeding, aquarium, botanical gardens, biodiversity parks. Of course, these biodiversity parks, there are a recent introduction, of course, with the support of Kerala State Biodiversity Board. We have started many biodiversity parks in various panchayats, Gram Panchayats, in support of Biodiversity Management Committee. Then Miyawaki Forest is another one, butterfly gardens. Then in agrobiodiversity, these kind of things: plants bank, animal seed bank, field gene banks, in vitro gene banks. Well, globally, Biodiversity International, they are doing human service for the conservation of agricultural germplasm, and they also help various countries. And they have an estimated 7.4 million accessions are currently maintained globally through their efforts. Well, in India, we have this NBPGR, National Bureau of Animal Genetic Resources, National Bureau of Agriculture Important Microorganisms, National Bureau of Agriculturally Important Insect Resources, and National Bureau of Fish Genetic Resources. So there is an attempt by ICR and Indian government to protect and maintain our germplasm. Well, I think I will stop here. Thank you very much. And even though there was a technical hitch, I could complete it. Thank you very much.
Thank you, sir. Thank you so much for providing us information on different protocols on biodiversity conservation, the different threats on biodiversity, and various conservation strategies, and also for the need to for the society to be informed about the biodiversity conservation. Thank you so much, sir. Thank you. Now we have Sri Biju B, who works as the District Environmental Engineer at the Kerala State Pollution Control Board at Kottayam. Previously, he served as Environment Engineer in the charge of NGT session, river rejuvenation, hazardous waste, and C&D waste, noise pollution, etc. at Kerala State Pollution Control Board, Head Office at Trivandrum, and also the District Environmental Engineer at Alappuzha, Trivandrum, and Palakkad, and who has been serving Kerala State Pollution Control Board from 2008 onwards. He has been part of several government level committees like Periyar Rejuvenation Committee, Coastal Pollution Action Plan Preparation Committee, Technical Committee, member of Sujitwa Mission for Wastewater Management, etc. He has published several technical papers and has won several awards for his efforts in environmental conservation. It's indeed my pleasure to invite Sri Biju for the talk on sustainable waste management. So please.
Thank you, madam. Thank you, organizers. I would like to extend my sincere thanks to Sudhir sir, present Chairman of Science and Technology, and our former Chairman of Kerala State Pollution Control Board. Let me share my video presentation. Madam, is it visible, madam?
Yes, not in the full screen, sir. Now. Yes.
Okay,
yes.
madam.
Yeah, fine, sir.
Okay. So my topic is sustainable waste management. Waste management is one of the major issue we had been facing. We had been in Moon, we had been to Mars, and so many scientific achievements India can boast on. But still, one of the major problem we face is waste management from all sources, from solid waste to liquid waste to all sort of things. And we had been doing something innovative in Kerala State Pollution Control Board. And thanks to Sudhir sir, when he assumed the charge of chairman, in addition to science and technology and all other 5 research institutes, he had kickstarted an innovative approach to waste management. And obviously, the circular economy, sustainability, and climate resilience are all the part of our initiative in waste management. Okay. We all know there are a lot of entrepreneurs who had been making innovative pathway from converting waste to wealth. One such enterprises is Code Enterprise, which convert the butts of cigarette to value-added product. And the other is Anil's Creations. They convert all lots of waste material for the recreational purposes. In a similar way, Waste to Wealth program kickstarted by our Honorable Prime Minister, what has also joined hand with the Kerala Scrap Merchant Association. And we had been given number of training for them to come to the forefront, the unorganized sector for collecting recyclables and attaining value chain. And now they launched their own software background or software program called Agricada for the collection of different sort of waste material and improving the value chain and ensuring circularity in economy. The other major achievement, Kerala State Pollution Control Board had done extensive training for the rack pickers or informal sector waste collectors and integrating them to the mainstream by giving proper licenses and training and quantification of their collection material and how much they contribute and informing them that how much they are contributing to the economy and cleanliness of our country. Second is we had been focusing on students. It's based on the story of Julia. She had been single-handedly struggled to protect a redwood tree by the municipality in California. They had decided to remove an old tree, but she nearly 1,000-year-old tree as a part of development. But she single-handedly struggled to protect the tree and eventually she won. By getting inspiration from this story, we launched a program called Mentoring Young Environmental Leaders for Transforming Alappuzha District. With the support of Sudhir sir, we extended the program for entire state, and total students participation nearly 5,600 in June, and it's reached 6,500 in July. And we had been collected nearly 150 tons of recyclable materials through the recyclable material collection campaign of students. And net carbon footprint we save by recycling is 552 metric ton by collecting 112 metric ton of recyclable material. Students who had started their own MCF, material collection and material recyclable facility in their own houses, and a zero carbon waste initiative they put forward become an example and inspiration for many people. By getting the inspiration from students campaign, the local church people in Erupuna put forward their support, and they had also collected recyclable material worth 72,000. The people in congregation also given a same amount as their support, and they collected, they procured nearly 15 tablet for students who deprived online education hardware for their education. And another initiative, students who involved is St. Joseph Higher Secondary School, Malayatu. They participated in the campaign and single-handedly grown 100-meter shore area of Periyar River with the wetweed for shore protection and erosion prevention. And public campaigns are also being a part of the campaign, and number of students and elders are also participated for rejuvenation of pond, lake, and groundwater, which something is happening with my next, sorry. Is it visible, madam? Hello?
Sir. Visible, sir.
Hello?
Visible, sir.
Okay. Okay. One of the great initiative we had been achieved in our sustainable waste management campaign is development of mobile septage. During the flood time of 2018, we had received support from UNICEF for sanitation service. They provided us 5 prototype mobile septage treatment facility for Alappuzha district and later for the entire Kerala. By using these facility, we had been treated nearly 5 lakh liters of sewage in Alappuzha and neighboring district. By taking inspiration from this, we developed a mobile septage treatment system for houseboats in Alappuzha, and which has been causing a severe pollution in Vembanad Lake. Later, we developed a mobile version for seafood processing industries, a scaled up version of a previous system. Then we went for a 50,000 liter mobile septage treatment farm for Alappuzha district. Then we introduced the same system for festival pollution control in Kanichukulangara and Amrita pilgrimage in Thrissur, Kozhikode, and Ernakulam. This is another form of a septage collection system. This is a mobile septage collection and treatment system for houseboats in Vembanad Lake, an advanced version. Another example I would like to, sorry. I would like to present is domestic biomedical waste collection model. We had been obtained support of 60 hospitals, private hospitals across the district. And with their support, we provided additional bin for collection of domestic biomedical wastes from various sources. So the patient who can visit the hospital in second and third time can dispose their biomedical waste in the specific bins provided in those hospitals. Another is used oil collection model. Dumping of used oil from automobile sector has been a serious hazardous and environmental damage issue in our state. We created a campaign for the collection of all these waste and sustainably process them for value addition. Another campaign we focused is the recyclable battery collection, waste collection. We meticulously followed up with all these battery shops and service stations and ensure the proper collection and recycling of these battery waste. Sorry. Another is the Evs Collection Campaigns. Such campaigns have been extensively done across the state for the collection from government offices, private industries and institutions, and ensure the proper recycling. And two more examples, if time permit, I will tell two more stories of sustainable waste management from industrial sector. Ma'am, do I have time?
Yes, sir. Very quickly, sir.
Okay. One is the RB aquatic industry, which is fish meal processing industry. We start an experiment there by using fish cut waste from seafood export unit for the value addition. During the time of COVID, the price of sardine and other small fish shoot up due to non-availability of all transported fish from other state. So this industry faced a severe raw material crisis. That time, we tried to utilize the fish waste produced in the cold storages where fish has been cleaned and only the meat is being given to the customer. Eventually, this industry started to collect all those cut fish waste from Alapi district and neighboring district with a 100 tons per month target. Now they are processing 1,000 tons of fish cut waste from Trivandrum to Thrissur from various fish sailing outlet, which had been cutting and cleaning waste fish for the customers, and they are keeping the fish waste in a freezer. This industry is collected all these fish cut waste to their fish meal processing industry, and now they are producing nearly 1,000 tons of fish cut waste processed fish meal and fish oil. Second example is autocast in hello. Hello, am I audible?
Yes, sir. Yes, sir.
Okay. The second example is autocast, which has been producing cast iron product. As a part of their processing, they generate a waste called score sand, it containing iron. It has been dumping around the unit for last 30 years. The iron is being exposed to sunlight, is oxidized to ferric form, and while leaching it with rainwater, it's contaminated the groundwater. The entire area around the autocast is being contaminated with a severe iron content. Its brown water is getting in all these groundwater wells. We find a solution with the help of CSIR. We utilize this score sand produced in the foundry industry for making brick and other value-added construction material. Now, as a part of 100 days program of our state, they have been producing 600 tons of solid brick out of this score sand. So these are the two innovative ways we adopted industrial waste for the value-added production, value-added product production. Thank you, madam.
Thank you so much, sir. Thank you for providing us the information about the different approaches for sustainable waste management, and also great to hear the different innovative programs undertaken by Kerala State Pollution Control Board for that. Thank you so much, sir. Thank you. Now we have Dr. Abhesh Raghuvaran, who serves as the Assistant Professor of the Center for Science and Society, CSIS, at Cochin University of Science and Technology. Previously, he worked at Integrated Rural Technology Center, Central Coir Research Institute, and in 2019 joined the Center for Science and Society of Kcsd. He serves as a judge in district-level science fair competitions for 15 years and writes science columns and articles in various leading newspapers and magazines in Malayalam. He has to his credit several publications in international refereed journals. It's my pleasure to invite Dr. Abhesh Raghuvaran for the invited talk. So please. You're on mute.
Now,
Yeah, audible.
most respected Dr. Pradeep Kumar, Professor KP Sudhir, Dr. Anil Kumar, and my dear friends, colleagues, and all. So this is my privilege to have a presentation connection with the showcasing and celebrating achievements of the last 75 years through Azadi Ke Amrit Mahotsav in connection in association with the KSCSTE. So I am directly, with the consent of the time, directly going to the presentation. The carving out of the society and nation through scientific temperament. Myself, Dr. Abhesh Rekhuvaran. I am from Cochin University of Science and Technology. Not moving. Yeah. So first of all, we should understand what is the scientific temper. As we know, Jawaharlal Nehru, our first Prime Minister of India, in the discovery of India, he writes, the scientific chamber is of course a way of life. It's an individual and a social process of thinking and acting, which uses a scientific method. For all the scientific methodology, we should follow a scientific method which includes the questioning, observing, reality, testing hypotheses, analyzing, and communicating. So he is one of the pioneer in the field of the science and technology, which has its own involvement in the scientific development of our country. So we should just go through the scientific advancement in India. We know the modern India has had a strong focus on science and technology, realizing that it's a key element for economic growth of our country. India is among the topmost countries in the world in the field of scientific research and positioning as one of the top 15 nations in the field of scientific innovations. As of 2021, 70% of 50 most innovative firms across the world have a research and development centers in India. A greater number of research centers and higher educational institutions makes the country pioneer in science and technology. As of November 2021, the number of universities, the higher education universities in India is stood at 1,019. It's a big number. So we had all of these kind of things. On the other hand, India's rank in Human Development Index is not below 10 or 20. It is 131. Why is it so? It is nothing but due to the lack of fair share of scientific interventions to the society. We have all the scientific innovations, developments, but it is not evenly distributed to all the peoples of the country. We can come to science and society, which is the main thrust area today we are discussing. Science influences society through its knowledge and worldview. Scientific knowledge and the procedures used by scientists influences the way many individuals in the society think about themselves, others, and environment. And in addition to the science, technology influences society through its products and processes, and also influences the quality of life and the ways people act and interact. Technological changes are often accompanied by social, political, economical changes that can be beneficial or either detrimental to the individual. The scientific and technological interventions either may affect beneficial or, of course, detrimental to the individuals and to the society. And we can come to, from the society, we can come to the nation. To correlate the science and the nation, science hold the key to the present and future development of the country. And of course, technology play a fundamental role in wealth creation, improvement of the quality of life, and real economic growth and transformation in any society and nation. So we are celebrating our 75 years of independence. We just go back after our independence. That is 76 years of independence. We just, in a nutshell, we can discuss about the 7 defining science and technology contributions that have impacted every Indian. As we know, first of all, the Green Revolution, which has happened in 1960s. That is a period that began in 1960s, during which the agriculture in India was converted into a modern industrial system by the help of technology. Thereafter, we witnessed White Revolution in 1970s. Thereafter, the satellite and communication revolution happened in 1980s. After that, there's a great boom in the field of medicine. Drugs and vaccines manufacturing happened. And thereafter, the CDOT and telecom revolution happened. IT revolution and railway computerization happened. And recently, the Blue Revolution, the upliftment, the revolution in the aquatic field, the fisheries field. All these advantages, all these developments, the advantages of all these interventions are not evenly distributed all over the country. Majority of the interventions are limited to the walls of universities and research institutions. These two things we should keep in mind. The advantages I have mentioned the last 75 years, great revolutions. The advantages of all these interventions are not evenly distributed. And also, as we know, in the university, the scientific interventions happened in the higher research institutions, higher educational institutions like universities. All are limited to the walls of the universities, either universities or the research institutions. So why so? This should be a bridge. There should be a bridge between the education institution and the society. It should be needed a bridge between the education institutions and to the society, which is very, very well needed for imparting the scientific interventions and knowledge to the society. For that, I just put forward a kind request that we need to establish some center of excellence for the dissemination of science to the society, which is very essential to meet these challenges. But unfortunately, there is no such provisions in our educational and research institutions. We are very much discussing about the impact, the dissemination of science to the society. But in real, unfortunately, there is no such provisions in our educational and research institutions for the dissemination of the science and technology to the society. I just make this as I'm not going through much about all these kind of things. I just taking this as a case study about my department, my own department, that is Center for Science in Society in Cochin University of Science and Technology. I just make and put forward this is a model for whatever I have mentioned before for the dissemination of science to the society. The Center for Science in Society, which is established in 1991 as a proceeding of 77th Indian Science Congress, which is conducted in Kochi University of Science and Technology. The focal theme was in that Science Congress was Science and Society. Great visionary, Dr. S. Pal, was a scientist, educationalist, was the president of that occasion, Indian Science Congress in 1990, put forward to establish a center in the university for dissemination of the scientific intervention to the society. We just mentioned he's a great visionary. We just mentioned that there's much discussion is not enough. So we need some physical centers for collaborating and consolidating all the findings in the university or the research stations, and which is needed, which is put forward their efforts to imparting dissemination the science intervention to the society. So about our department, it is the first of kind in the country that is center exclusively for students, school students in a university. The center has been visited by more than 2 lakh students and 8,000 teachers so far in the past 22 years. We are starting from students, of course. For any kind of such activities for disseminating the science to the society, we need ultimately the help of the students. They are the future of today for the country. That scientific temperament and scientific vigor in the students are to be realized during their school days and must be encouraged. We have to confirm, we have to check whether the students, any students have that much scientific temperament. So that have to be realized in during their school days itself and must be encouraged. Our center possesses a number of scientific simulations, scientific paths, and labs which can ignite the scientific attitude inside those young minds. We target the dissemination of the scientific thoughts to the students, which eventually reach their families and the societies, and ultimately, which is make use of the development of the country. This is about our university, Cochin University of Science and Technology. There are 30 departments in various disciplines in our university. More than 100 research papers, international research papers are getting published each year from these all departments. But the saddest part is that innumerable findings in those research papers are still sleeping in their thesis. It is not the problem of our university. In all of the universities, I'm sure, in all of the universities in the country, a lot of research papers are published here, but the findings in that research papers are still sleeping in each scientist's thesis works. Those findings have to be rediscovered to spread the light of knowledge to the society. That findings have to be let it fly in the air and it reach to the society for the upliftment of the society and to the needy. Our center also conducts studies about the basic problems and needs of the societies through the village adoption programs. We have adopted 2 villages and we have studied what are the societal problems they have facing. And in the meantime, we are coordinates the Department of the Cochin University Science and Technology to establish the solutions of their problems. The problems are variety of kinds. So we have checked whether any of our department have to solve these problems, and we are coordinate such problems, such findings, and we just depart. We have disseminate that technology to that needy society, needy villages, and by the village adoption program. Then we can come to the role of research institutions in the national building. Taking this as a model, I'm just briefly mentioning the activities of our department. So I request all the science and technology officials here, taking this as a model, universities and research centers all over the country should establish the center of excellences to bridge the gap between the society and the research community. That's very essential. And also a state level implementation of the project can be established through the coordinated activities of the local bodies. The local body, the help of the local bodies is very essential for establishing such activities. And of course, the state aesthetic councils like KSCSTE, I know they are doing a lot of activities in a well-equipped manner. They can take up the activities to the Department of Science and Technology at national level, which eventually will contribute towards Atma Nirbhar Bharat Abhiyan aims at national building. So I request all the higher education and higher educational institutions, scientific institutions to to taking this as a model and make sure to implement the project by establishing center of excellences like ours to impart, to disseminate the science to the society, which are already collected from each research institute and the university. So at last, I just finish with the great quote of Henry Frederick Amiel, that is, society lives by faith and develops by science. So I take this opportunity to thank all the officials, Professor Kcsd sir, Dr. S. Pradeep Kumar sir, of course, Dr. Anil Kumar sir, for providing me such an opportunity in a very limited time. And of course, thank you for KSCSTE, all the institutions, for getting me, providing me such a chance. Thank you very much.
Thank you, sir. Thank you for providing insights on the need to disseminate scientific knowledge to the society for the development of nation, to stress on the need to translate the research findings for societal benefits, and for detailing the activities of CSIS. Thank you so much, sir. And now let's hear the views and experiences of a scientist involved in the societal outreach science programs of KCST, and also from the awardees of some of the programs of KCST. We have with us Dr. Sija Thomachan, the Assistant Professor at Department of Home Science, College of Horticulture, Kerala Agriculture University, to share her experiences of the societal outreach program coordinated by her. Over to you, ma'am.
Thank you, madam. A very good afternoon to all. Respected Member Secretary, Dr. S. Pradeep Kumar sir, Dr. K.P. Sudhir sir, other distinguished scientists and participants. First of all, let me take this opportunity to thank the officials as well as the organizers for giving me an opportunity to share the experience of the project which was funded to me by KCSTE under the project BIRD, Biotechnological Innovations for Rural Development. So I thank for giving me the opportunity as well as for the funding received. So let me share my presentation. Hope it is visible.
Yes. You can make it in full screen.
Okay. Is it okay now, ma'am?
Yes, yes. Yes, sir.
So the project which was sanctioned to me was on value addition and product diversification from matured coconut water. What was the relevance of this project is that we know there are a large number of copra processing units, oil expeller units across our state. And one of the major problems faced by these units were the wastage of coconut water. The entire coconut water is wasted from these units, and this could be effectively utilized as forming a byproduct or as an additional source of income by converting the sugar present in this coconut water to 4 to 6% acetic acid, that is natural vinegar. Apart from this, there is another byproduct which can be prepared from coconut water, that is called as nata de coco. Nata means to float, and it is derived from coconut. That's why it is called as nata de coco. And this is produced by the fermentation of coconut water, and it can be done either by using the microbial culture Acetobacter phyllenium, or with the help of a mother culture also we can do it. So we were not having the production protocol for this nata de coco, and usually it's very common in the international market, but nowadays it's common in our supermarkets also. But we were not having a clear technology, a solid technology for the production of nata de coco, which could be done by the oil expeller units or by the copra processing units. So as this nata de coco, we know it's used as a health food or as a functional food because it's high in dietary fiber with low fat and zero cholesterol content. And since it is high in dietary fiber, it can be used for the prevention of lifestyle diseases like obesity, diabetes, and for heart patients, and even for reducing the cholesterol and all. So it can mainly be used as a dessert, and we can also experiment. We have also experimented various products with this nata de coco. And what is the practical utility of this study was that to reduce the wastage of coconut water from oil expeller units so that they can fetch an additional income by the production of vinegar as well as by the production of nata de coco. So they will get an additional income. And the main objectives of the study was to standardize the protocol for the production of nata de coco. And this we have done using both the bacterial culture and mother vinegar. And what all products that can be prepared from this nata de coco, and the quality attributes and the shelf life studies were studied. And the entire thing was done with the funding of KSCSTE only. And the technology, once we have standardized the technology has been disseminated for the production of both coconut water vinegar and nata de coco. Even now, I'm very happy to say that even now, many of the Krishi Vigyan Kendras across the state is asking for this technology so they can use it for their frontline demonstrations. And we have also, this project has also enabled us to develop entrepreneurial skills in branding and marketing. So the first stage, what we have done is the optimization of technology for the production of nata de coco. It was done both using bacterial culture and mother vinegar, and the quality attributes were analyzed. That is, the organoleptic qualities were done, the nutritional attributes like the carbohydrate, protein, because once if they want to sell their produce, the license is compulsory. They should have FSSAI license, and it is mandatory that the quality attributes should be indicated on the label. And it was experimented by incorporating this nata de coco in various RTS beverages. And we have also conducted the shelf life studies for a duration of 6 months, so as to ensure that it's safe for the entire period for sale. And we have imparted trainings, and now also the trainings is being continued in different KVKs, and from the funding of KSCSTE, we have given for 50 beneficiaries of Thrissur district. And we have, apart from this, we have also given them an idea about the entrepreneurial skills which is required for the marketing and branding of the produce. So these were the results of the study. We have optimized the technology using bacterial culture and mother vinegar. And for mother vinegar, the other ingredients used were sugar and ammonium sulfate to get the nata, which is of 1 inch thickness. And it only takes 14 days for the entire process. And even we can use it with the mother culture, and we can also prepare nata using the microbial culture. The Azotobacter silene culture was also procured from the Pune, and we have also standardized the technology using the culture. And all the quality parameters were studied during the period, that is including the organoleptic, the shelf life studies, and nutritional qualities. And it was found that all had very good scores, and the quality attributes were excellent, and it was found to be acceptable in the study. And this was also experimented in various products, like it could also be marketed in sugar syrups, in RTS beverages and all. So we have also experimented that, and the quality attributes of the products were also studied, and we could see that they were also acceptable to the consumers. And this was done by using a consumer acceptability studies, and it was conducted among 20 selected judges, and the products were found to be very acceptable. And these are the glimpses of some trainings which were conducted by the funding of KSCSTE. From the fund received, we have given several trainings to the beneficiaries, and the beneficiaries which were selected were all having this oil expeller units, and so they too had the problem of the wastage of the entire coconut water from the units. And so these are the glimpses of the trainings given, and I should proudly say that several units were established in different parts of the district. Even in Kerala Agricultural University, there is one unit for the sale of vinegar. And apart from this, we can see the plates where we have established several units, and we could provide the inputs from the funding received from the state. And we have given some inputs also for them for the production. A small vinegar generator and all was given to the units, and so they could establish. And for the dissemination of the technology, we have prepared several books also for vinegar and for the production of Natadi cocoa. And even now it's being distributed to the beneficiaries through KVKs. So I take this once again. I thank KSSTE for giving me the funds for doing this project, and I'm very happy that I could disseminate the technology. Even now, even yesterday, we had a call from Wayanad for the technology of Natadi cocoa and vinegar production. So thank you once again. That's all from me.
Thank you so much, ma'am. Great to hear the technology developed from KAU through the Biotechnology Innovations for Rural Development, the BIRD program. It benefited the society. And great to hear that. Thank you so much.
Thank you. Thank you.
And now we have Srimati Neetu Emmanuel. Let's hear from her. The awardee of the PAIR program, the Partnering Academic and Industrial Research Program of KCST, who's currently the optics engineer at Winwish Technologies Private Limited, Trivandrum, about her experiences. Over to you, Neetu.
Thank you, ma'am. Good afternoon, all. First of all, let me thank DST and Kerala State Science and Technology Council for giving me an opportunity to share my research experience on the PAIR program. Myself, Dr. Neetu Emmanuel, I have very recently awarded PhD degree in engineering from CSIR NIST through the PAIR program. I must say PAIR, the Partnering Academic Industrial Research Program, was a unique and a wonderful program launched by Kerala State Council, Science and Technology Council in the year 2017. And the main agenda of this research program was to promote translational research through the collaboration of academia and industry. And I was very fortunate enough to be selected as the first candidate under this research scheme. And this program was organized in such a way that the Science and Technology Council coordinated and evaluated the progress of the work, provided financial funding for carrying out the work at an R&D institution. In my case, it was a CSIR NIST Trivandrum. The research institute provided facilities and guidance for conducting the research work. And there was an industrial partner, Winwish Technologies Private Limited. They provided financial funding by supporting the fellowship and also provided technical support. So the main attraction of this program were we are trying to find a technological solution for a social problem through the collaboration of research and industry. So under this research scheme jointly launched by KCST, CSIR, NIST and Winwish Technologies, I registered for a PhD in ACSIR at CSIR NIST in January 2018 under the guidance of Dr. Yusuf Karuvat and Dr. Narayani KN. And talking about my research work, the research work mainly focused on developing portable Raman spectroscopy based methods for on-site analysis of pharmaceuticals. So one of the major threats to public health in the past few years is the dramatic increase in the counterfeit drugs. So various reports says that India is also a leading source of counterfeit drugs, and this is mainly because of the lack of easy and fast on-site testing facility for their detection and prevention of these kind of counterfeit or a fake drug. So this poses a major challenge to public health safety officers to identify and discard these poor quality medicines which are available in the market before they are reaching to the consumers. So instead, a portable and a handheld device that can detect the quality of these kind of medicines without the need of a trained professionals will be an ideal solution for this. So in my research work, we developed a portable and a low-cost Raman spectrometer for identification of the chemical content from various materials. And the device was made at a cost of less than 1 lakh. And while comparing with the commercially available devices, this cost is relatively very less. The commercial devices cost a minimum of 10 lakh, or it can go up to 1 crore depending upon the device functionalities. And also our developed system has a huge potential, and it could be configured to be used for various applications other than this pharmaceutical product analysis. Like it can be used for detecting adulterants from various food products like edible oil, etc. So I strongly believe that this research work has great importance and useful to the society by ensuring the quality of the pharmaceutical products supplied to the consumers. So as Dr. Anil has mentioned in his talk, this development of the low-cost Raman spectrometer has been recognized at national level and received a CSIR award for the best innovation in the year 2020. So by the immense motivation and the constant monitoring of the progress of my research work by the peer advisory committee members, I was able to make good progress in my research work, and it really helped me to complete the research work in a comparatively short span of time, that's 3.5 years. And as per the MOU, the sponsoring industry offered me a job after completion of this of my PhD work. And now I'm currently working as an optics engineer at Invis Technologies and at Technopark. And now I'm involved in various R&D projects, and we have also started studies at Invis towards commercialization of the portable device for chemical identification. I'm really feeling thankful to Kerala State Science and Technology Council for initiating such a wonderful program and giving me an opportunity to be the first beneficiary of this research team. Thank you all. Thank you for giving me an opportunity to share my experience through this platform.
Thank you so much, Neetu. Thank you for sharing your experiences. KCST is indeed proud of your accomplishments and the fact that this particular product has received the Technology Innovation Award of 2020. Thank you so much for sharing your experience. And now, Sri Akhilesh is an awardee of the APJ Abdul Kalam Youth Challenge Program of KCST. Since Akhilesh could not make out to here, having some prior commitments, Sri Deepak Krishnan will be presenting on his behalf. I request Dr. Sri Deepak Krishnan to please share the experiences.
Thank you so much. Myself, Deepak, I am working and will be speak on behalf of Akhilesh. We are working together for the Youth Challenge program. And first of all, I am thanking KSCSTE for giving this such a wonderful opportunity for us. So basically, let me start talking about our product. Our product is a device which can be used for hearing disability issues, hearing disability issues. So it is estimated that almost 430 million people in the world have the issues of hearing by 2030. So the market is very big, and we are in need of a low-cost portable device. That's the reason why we have started looking into this kind of innovative product. And we reached KSCST Council in 2016-17, and as a part of the Youth Challenge program. And we have got the investment of almost an initial investment for the prototype development, and we have used that, and we have successfully developed the prototype, and we have tested with the people. Finally, we are able to come up with a low-cost product which will be useful for the poor people or the weekend sections of the society. Our aim is basically to develop a product which is useful for the poor people, as well as to develop a very good product which can be commercialized and able to do business in the market, and that should be economical also. That's the reason we have come up with a very good design, and finally we have got the investment from the KSCSTE for the product development. With that amount, we are now in the first phase of the product development, and we have started the design freeze. Within 2 years, we have probably come up with a product which can commercialize into market. Obviously, we will come up with a product, and that needs mass manufacturing. So this manufacture, with the help of council, hopefully we can mass manufacture this product and make it available for the external market. And before talking about the experience what we have with the council, me and Akhilesh, we worked almost 10 years with council. We started with a product called iBoon, which is useful for the visually impaired people. And we have made a prototype. Now we are in a stage where we will be able to commercialize that product also. So thanks to the council for the entire support for developing the prototype of iBoon. And now the second project, Acute, we are in the development of product development, and we hopefully we can complete that within 2 years, and we can commercialize that into market. Talking about the support which we received from the KSCSTE throughout the last 4 or 5 years, and also we are doing this along with the Trust Research Park, and we have got immense support from both the people who are there at the council and also from the Trust Research Park. And also I should give our sincere gratitude towards the niche who support us in developing the product throughout the 4 or 5 years for the development of Acute. Yeah, so hopefully we can sit here in the later stage of the product development, and we can show you a wonderful product that can be available in the market. Thank you for this opportunity, Ansel. Yeah.
Thank you so much, Deepak, for sharing those experiences, and we wish you all success in developing of the product, having commercial potential. Thank you so much.
Thank you.
And Sri Eldos Raju from Vishwajyoti College of Engineering and Technology, Muvatupura, is a student project awardee of KCST. And now let's listen to him about his experiences. Over to you, Eldos.
Good afternoon, all. My name is Eldos Raju. I am representing Vishwajyoti College of Engineering and Technology, Varakulam. My project was a separator. Let me show my presentation slide. Is it visible?
No, Eldos.
Okay.
You have shared it?
Yeah, I have shared that. Ma'am, is it visible now?
No, there's a share button at the bottom of the window. You can click that and share.
You can see a bottom. You can
Yes,
see a share icon at the bottom of the screen.
Okay.
So through that,
Ma'am, I'm not getting.
Join through mobile?
Yeah, ma'am. Actually, I'm in workplace and.
Okay. If you can send us.
Okay. Okay, ma'am. It's okay. Let me introduce my project.
Yeah.
Okay. So my project was a nutmeg separator. As we all know, nutmeg is one of the major cash crop in Kerala. So the aromatic compounds that is present in the maize and core of the nutmeg led to the continued usage of nutmeg as a spice. Also, nutmeg is used in pharmaceutical and cosmetic industries. So it is a cash crop having high medicinal value. So our project was to break the shell of the nutmeg and to take out the core of the nutmeg. This is because on analyzing the market, we can see that most of the farmers are selling the nutmeg with shell. That is, they will be removing that yellow colored flesh portion. They will be removing the maize, red colored maize, and they will be selling the brown colored seed of nutmeg. So the major problem is that the cost of the nutmeg seed is rupees 180 to 200 rupees per kilogram. So if we break the shell of the nutmeg and take out the core, the inner seed of the nutmeg, and we sell it on market, we'll be getting a price of around rupee 360 to 400 per kilogram, depending on the quality. So most of the farmers now, what they do is they'll be selling the nutmeg seeds without breaking that. So our intention was to make a machine to break the shell of the nutmeg and to take out the inner seed, so that they'll be getting high income from that. So the major objective was to increase the income of nutmeg farmers. So for that, we made a prototype. So it is an electrically powered machine. That is, we'll be inducing a rotation in a rotor by using an electric motor, AC motor. So as we know, the motor is having high rotational speed. In order to reduce the speed, we have used a speed reduction gear mechanism. So with the help of this motor, we will be inducing rotations in a rotor made using a GI pipe. So when the nutmeg is fed into this machine, its shell will be get break due to the impact of the rotation, and we will be getting the nutmeg seed in the bottom compartment. So by using this machine, we can simply break the shell of the nutmeg and take out the core, so that we will be getting more market value for nutmeg. So we have made a prototype and it was very successful. And let me thank KSCSTE for funding my project and also giving me opportunity to present my project. And I'm sorry that I couldn't present my PPT. Thank you, ma'am.
Thank you so
Thank you.
much, Eldos, for sharing the details of your project having a societal benefit. Thank you so much.
Thank you, ma'am.
And now we have Devananda IS, who is a class 12 student of Kendriya Vidyalaya, Calicut, who is an awardee of Crystal program of KCSD. Now let's listen to her.
Most distinguished dignitaries, I'm Devananda, studying in 12th standard at Kendriya Vidyalaya No. 1 Calicut. I feel immensely delighted and proud of being invited to this gorgeous program to share my experience of the Crystal Science Orientation Camp. I extend my deep and sincere gratitude to the officials of KCSTE for providing this unique opportunity. I'd like to begin with my experience of NCSE. I was fortunate to have participated in the National Children's Science Congress held at SOS University, Bhubaneswar in 2018. I presented a project on the topic, a comprehensive study based on traditional seed preservation techniques. The National Children's Science Congress is an exemplary platform that provides a conducive environment for science, culture, and feeling of our nation to fuse together. Student scientists from various parts of the country, even from ASEAN countries, come and present their innovative thoughts and scientific interventions for the benefit of society. So being a participant of the NCSE, I got the privilege of being selected for the Crystal program, Crafting Young Scientists for Tomorrow, a 5-day science orientation program organized by KSCSTE at ISER Trivandrum in May 2019. I still cherish the memories and experience I had, as it was a very well organized and beautifully executed program. There were 32 student scientists, all state level winners of NCSE from different parts of Kerala, to participate in the program. The participants were given a grandiose reception by the KCST officials at the venue. Students from ISER volunteered to provide all kinds of help and support to us throughout the program. On 16th May, the respected Executive Vice President of the KSCST, Professor KP Sudhir, inaugurated the program. Thereafter, we had around 9 outstanding sessions by eminent scholars from various branches of science. The participants were literally illuminated by the profundity of scholarships of the resource persons. They were all adept in translating abstract scientific and mathematical theorems into graspable language. The participants got a very wonderful opportunity to explore the natural diversity of the campus, which is located at the foothills of Ponmudi. And we found different varieties of birds, butterflies, and plants during our short outing with the resource persons. We were also lucky to have been given permission to conduct various experiments from the laboratories of the ISER campus. We became familiar with the lab equipments and their use, and resource persons and volunteers had been very cordial to us all throughout the program. Therefore, we were able to interact with them without any shyness or inhibition. Most of the sessions were activity oriented that sustained the interest of the participants, and the food and accommodation provided to us were also worth mentioning. So the 5-day Crystal program was indeed an unforgettable event in my life. The camp threw much light on the importance of scientific literacy in creating a sustainable and harmonious society. I've learned the fact that scientific understanding is necessary for the betterment of society. Then science and technology should cater to the needs of man without violating the environment. So the resource persons were very particular about nurturing scientific thinking in our day-to-day life. The practical learning experience provided by the Crystal program helped us understand complex scientific and mathematical concepts easily. It is with great excitement that I still remember my experience at the ISA campus. So I'm thankful to the KCST for providing us such a unique experience to all of us. And once again, I thank the organizers of this program for providing a unique experience to speak here. Thank you.
Thank you so much, Devananda, for giving a concise sharing of experiences, and very happy to hear that program benefited you a lot. Thank you so much. Thank you all for sharing your views and experiences. Now, let me move to my duties of proposing the vote of thanks. Most respected Professor Sudhir Sir, the Executive Vice President of KCSD, Dr. Pradeep Kumar Sir, the Member Secretary of KCSD, Dr. Suresh Das Sir, the former Executive Vice President, Dr. George Thomas, Sri Biju, Dr. Abhesh Raghuvaran, Dr. Srija Thomachan, Dr. Ms. Neetu, Sri Deepak, Sri Eldos, Ms. Devananda, Dr. Anil Kumar Sir, Dr. Debapriya Datta, the directors and scientists of R&D institutions, my senior colleagues and distinguished participants. This is the 8th program of the series of the program, which has been conducted as part of the Vigyan Utsav and on a very relevant theme, the science and the society. It was indeed enlightening to hear from different speakers on the importance of the societal impact of science and the scientific accomplishments. I profusely thank, on behalf of TST and KCST, Professor KP Sudhir, the Executive Vice President of KCST, for all the support and guidance in organizing the program meticulously. Sincere thanks to Dr. S. Pradeep Kumar, the Member Secretary KCST, who's the General Coordinator of the program, for all his efforts in the smooth conduct of the program. Thank you, sir. On behalf of KCST and DST, I express sincere gratitude to Dr. Suresh Das, who enlightened us with a keynote address. I sincerely thank Dr. George Thomas, the Chairman of Kerala State Biodiversity Board, Sri Biju B, Environmental Engineer at Kerala State Pollution Control Board, Dr. Abhesh Raghuvaran, the Assistant Professor at Center for Science in Society, Kcsd, for their informative talk on the theme. I wholeheartedly thank Dr. C. Anil Kumar, the Senior Principal Scientist at KCST, for coordinating the conduct of the program meticulously and for detailing the state and KCST programs on science and society. Our sincere thanks to Department of Science and Technology, Government of India, Dr. Debapriya Datta, Dr. Rashmi Sharma, Dr. Ravikant Prajapati, for all guidance and support. Our gratitude to the officials of different S&T councils for joining the program, and special thanks to Maharashtra State S&T Council for the necessary directions and guidance. On behalf of TST and KCST, I thank the directors and scientists of R&D institutions for joining us. My sincere thanks to the scientists, administrative staff of KCST for joining, and many thanks to the NGC coordinators and the representatives from different schools from throughout Kerala for joining us today. Thanks to the technical team at KCST, the Information Systems Division, for managing the online platform effectively. I sincerely thank all the distinguished participants for their wonderful participation. I'm sure you all had a great time and would have much benefited from listening to the speakers. Thank you one and all. We now conclude the program. We'll meet you with the next theme next month. Thank you so much. Now, National Anthem.
जन गण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल गंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता